Okay, hey everybody. This is actually my third time streaming this because I discovered in trying to explain linear inequalities that there were definitely opportunities for me to learn how to explain this better. As I went through it, I was like, oh my god, that's a bad way to explain it. So it goes to show you never stop learning, okay? I know linear inequalities like the back of my hand, easy, but communicating it is different. Here's where we're going to begin, okay? First of all, if you haven't already seen the linear equations video, please see that first. You need that to survive this. You got to be comfortable looking at lines. You got to be comfortable interpreting what's going on them, okay? If you need to, go see that first. Please also remember with all of these videos to pause and try to work it out yourself. That's where all of the confidence comes from, and that's where all your gains come from. You don't get muscles from watching somebody work out. You get muscles from lifting and working out. Likewise it is here. Let's begin. Okay, for linear inequalities, all right, we're dealing with graphs that have more than one line, okay? The word linear, as in line, and inequality, as in not equal, in equal, okay? Because of that, and I'll show you some of these previous iterations, okay? Because of that, you're going to have more than one answer, okay? You will always have more than one answer. And the reason for that is, think about this statement, y is less than 5, okay? If y is less than 5, then y could be 4, 3, 2, 1, 0, negative a million. Y could be a whole bunch of things. Because of that, you're always going to have lots of answers when you're dealing with inequalities, okay? Let's start off with a graph, and I'll show you what that looks like on here, because I know you can clearly see with your eyes 4 is less than 5, 3, 2, 1, 0, negative a million. You can see that all these are less than 5, but how do you show that on a graph? That's what we're going to do here. Let's start with y is greater than 2x plus 3, all right? I'm going to go ahead and graph this, and if you've already seen the other video on graphing, then you can already see where this is going. I'm going to put my y-intercept here at 3. Then I'm going to go up to, I'm going to go ahead and count this, y'all. This is kind of in between pages. I'm going to go up to and over 1 and connect my dots to make the line, okay? Now, you use a solid line whenever you have an equal to, and you use a dotted line whenever you do not, when there's no equal to sign there. I'll go over why in a minute, okay? But just a lot of people do fine with remembering solid line means equal to, dashed line means not equal to, okay? If you ever forget that, just look. The equal to part of an inequality is a solid line. So it's kind of hard to miss. Okay, fine. The question is, where are all the answers? Okay, for answers with an inequality, you shade. So you either shade below the line like this, or you shade above the line like this. The question is always, where do you shade? Are you shading above where the orange is, or are you shading below where the purple is? Which one is it? That's what we're going to talk about. The best way I know to describe how to shade, where to shade, because after a while you can actually eyeball and see where to shade. And that's what I was trying to communicate to y'all before, but clearly I don't know how to communicate it well enough to tell you how to eyeball it. So instead, I'm going to teach you a real solid way to tell that will work with you 100% of the time. Here's what you do. Remember that your answers are always going to be either below the line, and remember, we're always talking about below the line or above the line. So it's the line is everything. You've got to make sure you get the line drawn first, okay? Here's how you can tell. Anywhere your shade you are claiming is an answer that makes your statement true. So if you shaded below here, what you're saying to everyone is that it doesn't matter what point you pick that's down here, all of the points will prove this true. Here's what I mean by that. let's take the point 0, 0, actually. And by the way, anytime you can use 0, 0, use it. If you say 0, 0 is part of your answer, you should be able to take it and put it into the equation. Here, let me point at it right. Okay? So I'm going to put 0 in for y and for x. So I'm going to rewrite the equation here first. Let's do 0 is greater than 2 times 0 plus 3. Whoa, 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 Mike. Why in the world are you putting zeros in here? Where did that come from? It came from right here, my friend. Why'd you pick 0, 0? Why not something else? We're trying to pick any point that is here in this green area. Because remember, we're testing to see if this green area is the answer. Because remember, we're always going to have more than one answer for inequalities. So we're always talking about an entire area that is either below or above the line. It is either in the green or it is above it, right here in this red. It's one of those two. We're just testing out to see if it's in the green or not, okay? So fine, I took 0, 0 because it's the easiest point. 0 is not hard to plug in, okay? You're going to get a bunch of zeros for that, all right? So let's pick up where we left off now that you remember y. Y is greater than 2x plus 3. If we put 0 in for y, because y is 0 right here, and if we put 0 in for x, because 0 is x right here, okay? Then we can solve it. We go 0 is greater than 2 times 0, which is 0, plus 3. Therefore, 0 is greater than or equal to 3. Is that true? Is 0 greater than or equal to 3? That would be a no. Okay, that's impossible. 0 is not greater than 3. It's not. Because of that, this cannot be an answer. Mike, what do you mean it's not an answer? It's a point on the graph. Yes, it's a point on the graph that's below the line. And if you think the answer is below the line, then it should be true. But we just put it in. It's not true. This is not possible. So this green area cannot be the answer. Let's erase it. It cannot be the answer. Instead, let's try above the line. Because remember, I told you your answers will always be either above or below the line. Okay? I'm going to shade the area above the line. We're going to take any point that's in this shaded area. And remember, I shade the area first so it's easier to see. You don't technically have to, well, no, you do have to shade your answer. But take any point that's in the shaded area, okay? In this case, again, I always go for something that has a 0 on it. I just don't believe in working harder for no reason, okay? So let's shade it again since I accidentally erased it. And I'm going to take a point that's on the y-axis that is, that way the x can be 0. So let's try this point right here, okay? What is that point? Let's count it. 1, 2, 3, 4, 5, 6, 7. Okay, so that is 7 on the y-axis. And the x value is 0 here because I'm on the y-axis. So the x has to be 0, okay? So fine. Y is greater than 2x plus 3. Let's plug this point in to the equation. So let's go y. Here, I'll put it up here so you can see it better. Y is greater than 2x plus 3. Let's put 0 in for x. So y is greater than or equal to 0. Or I've skipped a step. I'm not showing you that. 2 times 0 plus 3. And let's put in 7 for y. So 7 is greater than or equal to 2 times 0 plus 3. Therefore, 7 is greater than or equal to 0 plus 3. Therefore, 7 is greater than or equal to 3. Is that true? Absolutely. 7 is indeed greater than 3. This shaded region looks good so far. I recommend you take one more point just to make sure it's good. Okay? So let's take one more point and put it into the equation to make sure it's good. And again, if you're looking at this and you're kind of like, huh, I don't get it. Okay, let me walk you through one more go here, okay? Because I'm doing the same thing, just in different spots. Let's go with this point right here, because it's easy to see, and it's just over the line. This point is, let's see, So the x for this point is -2. We know that because here's the 0 for x, and we went over to the left 1, 2. So the x for is -2, and the y for it seems to be 1, 2. So this should be -2 and 2. Okay? I'm going to put this right here into our equation. All right? So let's do that. And I know it's getting kind of sloppy. Stay with it. So let's rewrite it right here. Y is greater than or equal to 2x plus 3. Let's put -2 and 2 into there. Okay? So -2 is the y. Or wait, sorry. -2 is not the y. 2 is the y. Do you see that? So 2 is greater than or equal to 2 times -2 plus 3. Mike, why are you putting -2 here? And why are you putting 2 over there? Because we chose a point. It's right here. Let me show you. We chose this point right here to test. Remember? And the reason we chose this point is because it's inside of our green area. Remember? Our bigger green area here. Let me highlight a different color. Remember, we're testing this whole area above the line. Because remember, your answers are always either above or below the line. We already tested below. We tried below over here, and that didn't make any sense. So now we're trying above. You can pick any point above. I just chose this point down here because it's easier. I mean, you can pick any point you want. If you find a different point, great. All right, but fine. That's why we chose -2 and 2, and we put -2 in for x because x is here, and we put 2 in for y because y is there. Okay? That's why we're here. Now, 2 then is greater than or equal to 2 times -2, which is -4 plus 3. So 2 is greater than or equal to -1. Is that true? Is 2 greater than or equal to -1? And hopefully you said, yes, 2 is a positive number. And yeah, it's bigger than or equal to -1. And that's true. Thus, our answer for this graph is this line right here. Let me highlight in orange because we have a lot going on in here. And you shade this whole thing up here. That is your answer for this one. The line and the shaded region above it. And it's a solid line because we have an =2 sign. Okay? I know this is jumbled in a lot, so let's work another one. If you're not sure what just happened, rewind it back and see if you can follow through, okay? Here's another one just in case. Let's take this line. Let's first create the equation for it. Y, I know we've got a +3 because I can see it crosses the y-axis at 3. And now I'm going to count the slope. Let's do it. Let's go 1, 2, 3, 4, up 4, 1, 2, 3, and over 3. So this should be y equals 4/3 x plus 3. And hopefully from last video you remember how we got that. Now, let's get us a straight line going. Really need a ruler. Okay. Now, remember for linear inequalities that there should be an inequality here. Okay? I don't have an inequality right now. I have an equal sign. So all of the answers for this graph so far would just be on the line because after all, it's just an equal sign. Let's make it an inequality by using an inequality sign. I'll make this less than this time. Now, you remember that the dash underneath should let you know that this should be a solid line that we have. So we do have a solid line, and we're going to keep that solid line because we have an =2 sign there. I'll show you what to do when you don't have an equal sign later. Let's go ahead and explore the answers for this, because remember, there will always be more than one answer. If you say y is less than 10, it could be 9, it could be 8, it could be 0, it could be -1,000,000, it doesn't matter. There's a bunch of answers when you have inequalities. Always. There's never just one answer. Most of the times, there's not just one answer. Okay, here we go. Never say never. Except for when you're saying never say never. All right. So fine. Here's how you test for your answers. Remember, plug in a value. Plug in a value. remember, I always recommend take 0, 0 whenever you can. Let's see if the answer is down here first. You know why? Because 0, 0 is down here. This, the origin, the middle, is 0, 0. So let's test it. Why, Mike? Why test 0, 0? Because it's easier. If you want to use other numbers, you go right ahead and knock yourself out. But I see a fraction here, and your boy's not trying to pile on extra work. Okay, let's do 0, 0. Now, so let's test it. Y is less than 4/3 x plus 3. Therefore, 0 is less than or equal to 0 times 4/3 plus 3, which means 0 is less than 0 plus 3, which means 0 is less than 3. Is that true? Yes! Okay, epic. This region down here is probably the answer. I say probably because I always like to double check. Here's how you double check an inequality, okay? If you have an answer, like we just did, 0, 0 proves true. 0, let me write it in a different color. 0 is indeed less than or equal to 3. So this shaded region is probably the right answer, okay? Let's make sure it's the right answer though. Let's take a number that's somewhere in here and put it in the equation. Because if we put it in the equation, the number from here should prove false. Okay? Let's try it. I like to take the easiest numbers possible. Work smarter, not harder. So let's go ahead and take this point right here, because it's on the x-axis and it's going to have a 0 in it. This point right here is, let's see, negative, here, let's use a different color. -1 is here, -2 is here, -3 is here, -4 is here. Let me label it so you can see. So -5 is here, okay? I'm choosing -5 because it is above the line. So it would be in the lines region if we were shading this direction. We're not shading that direction because we don't think the answer is up there. Why don't we think the answer is down there? Because we've already proved that it's probably down here. We're just double checking now. So back to what we're doing, the double check. This point right here is -5 and 0 because the x is at -5 and it doesn't go up any at all. So the y is 0. Let's put this into the equation. And remember, since we did not shade this, nothing in here should be true. This in here should all be false. We didn't shade this, so we're not saying this is our answer. What we're doing right now is trying to prove that this could not be the answer. So let's put this in here to see if it comes out wrong. 0 is less than or equal to 4/3 times -5 plus 3. Okay? Therefore, 0 is less than or equal to -20/3 plus 3. When we put that in a calculator, we get 0 is less than or equal to, here, let's stick that in real quick, -3.6 repeated. Is 0 less than -3.6? No! 0 is always bigger than a negative number, because remember, negative numbers are less than 0. Okay? So 0 cannot be less than a negative number. This statement is false. -5 can't be, this cannot be the answer. So we're right. Our answer has to be right. We just proved it two ways. We proved that it has to be right because this down here is true. The blue down here is true. We know that because our 0, 0 proved true. And this above it proved false because 0 cannot be less than a negative number. Therefore, our answer is the blue region. Okay? Now, if that last part kind of confused you, you don't have to do it, but I recommend, if you can, don't just prove your answer is right by picking a number in your shaded region. pick a number outside of it too to prove that it's right, because the number outside of your shaded region should be false, and the number inside your shaded region should be true. How do you know it's false and true? Put it inside the equation and see what happens. We did it here. We did it here and showed that it was false. This was impossible. And we did it here and showed that this was true. It has to be true. That's how you know your answer is right. And your answer should be the one that is inside the shaded region. Or sorry, your answer should be the shaded region, okay? Let's work a few more. If you didn't understand that, rewind it, because everything you need to know about finding the answers for these bad boys on a graph is in what I just said. Okay, let's work several more of these. Making us a few more graphs. Okay, here we go. All right, let's take this line here. All right, which is, and it's a solid line, so you know it has to be something or equal to. Okay, we're going to get to the dashed lines in a second. I just want you to focus on shading, not dash and solid lines. Most of you are going to be fine on dash and solid lines. And let's call this one greater than. Why not? Okay, y is greater than. What is this y-intercept? Let's see here. That is 1, 2, 3, 4, 5. So it must be plus 5. And then our slope should be, let's see, we're going to go down 1, 2, 3, 4, 5, and over to the right 2, 1, 2. So negative 5 over 2, x. Okay? All right, let's find the answers for this. Remember, when we're finding the answers for an inequality, the answers for an inequality, and it is answers, it's more than one, you have to shade. You have to shade whole regions for your answers, okay? Now, let's explore which region should be true for this. Remember, I recommend you take 0, 0 anytime you can. So let's take 0, 0. I'm going to see if this region down here is true or not. Mike, how'd you know to start down there? You don't. I didn't know to start down there. I'm just picking 0, 0 because if the answer is in there, 0, 0 will prove true. Remember, your answer has to be either below the line or above it. And because your answer has to be either above it or below, you can pick any point you want in those. So I'm going to pick the point below it, which happens to be 0, 0, and that's easiest. I don't know if it's true yet or not. We're just going to try it. So let's do it. Here is 0, 0. Let's see if it's true. Let's put it in our equation. Y is greater than or equal to negative 5 halves x plus 5. Mike, where'd you get that equation from? It will already be given to you. You don't ever have to wonder where the equation came from. It will either be given to you or it will be your job to come up with it, which I showed you in the previous video. Now, let's take 0, 0 and put it in there. 0 is greater than or equal to negative 5 halves times 0 plus 5. Anything times 0 is 0, so I'm going to go 0 plus 5. 0 is greater than or equal to 5. Is that true? Oh no! Okay? This is not true. So 0, 0 cannot be in the answer, which means I don't need to be shading this way. I need to be shading this way. Okay? Because if 0, 0 makes this thing false, the answer can't be in anything below this line. Got it? All you have to do is find one false statement and it's over. Everything in your shaded region should prove true. Everything. Lucky for you, you don't have to test all the points. Just test 1 or 2. Now, the neat thing about doing it this way is the minute you prove one is false, all you have to do is prove the other one is true, and you win. Okay? So let's take any point that's above the line and see if it's true. I like to take points that have zeros on them. That would be something on the x-axis or something on the y-axis. But if you don't prefer that, let's work one where it's just a point that's in the region. So I'm going to do this time 4 for the x, and let's do, let's go up 4 on the y. So 4, 4. So let's do 4, 4, okay? Let's put 4, 4 in the equation and see what happens. Now I'm going to write a little smaller so we can see it easier this time. Let's do y is greater than or equal to negative 5 halves x plus 5. And we're going to take 4, 4 and put it in there. Let's do 4 is greater than or equal to negative 5 halves times 4 plus 5. Therefore, 4 is greater than or equal to negative 20 over 2 plus 5. Thus, 4 is greater than or equal to negative 10 plus 5. Therefore, 4 is greater than or equal to negative 5. Now, if you're like, whoa, whoa, Mike, you're going too fast. It's just math. Pause it if you need to and kind of work through just plugging the things in. And I know it has a fraction in it. I know those are icky. So don't worry about if you got lost in the numbers. Here's what I want you to pay attention to. Is 4 greater than or equal to negative 5? And that should be an absolute yes. 4 is greater than negative 5 all day, every day, because negatives are always less than positives. This statement just proved true. Therefore, your answer is confirmed in this region. And since you already proved that an answer out here was false, you know for sure that your answer is in here. Congratulations. This right here is the answer to this inequality. All right? Hopefully this one is where you start catching on a little bit, where you kind of have like a, okay, I think I kind of see it. Let's work another one. This time I want you to pause me so you have time to work it, okay? I'm always going to show you after the fact, but please try to work these on your own, as that's the only place you really get confidence. Okay? Let's do a point through the origin just to make it interesting. Okay? All right. This is the graph of y is greater than or equal to, you know it's greater than or equal to because it has a solid line. See the solid line? Okay. Solid line. And let's see. We're going up 1, 2, 3, 4, 5, and over to the right 1. So our rise over run is 5 over 1, which is 5x. And then our y-intercept, where it touches the y-axis, is at 0. So 5x plus 0, which is the same thing. It's just y is greater than or equal to 5x. This is the equation for this line. Let's find the answers for y is greater than or equal to 5x. Pause me here and give it a shot. Remember, I said answers, so you're shading an entire region. You're shading an entire region. Remember, I also recommend testing the easiest points possible. If your mind doesn't mind, no pun intended, using something on an axis, do that because you'll always have a 0 somewhere. If you don't like that, pick something easy like 1, 1 or negative 1, 1, stuff like that, okay? Pause me now if you haven't and give it a shot. Okay? Hopefully you've paused because I'm getting ready to give answers. Okay? All right, here we go. All right, again, I recommend just picking a side to test a point in. So I'm going to start off by picking this side. All right? I don't know if the answer is in here or not. I have no idea. Instead, I'm going to pick a point inside of that region to see if it proves this statement right here true. And if it does, then it is the answer. And if it doesn't, it is not. Okay? And I need to check the other side if it's not. All right, fine. So here's a point. 1, 1. Super easy. So I'm going to take the point 1, 1 and put it into the equation to see if it proves true. Let's find out. Y is greater than 5x. Y is greater than or equal to. Let's put in 1 for both 5 and x because we picked easy. So then 1 is greater than 5 times 1. Therefore, 1 is greater than 5. Question mark? I'm sorry. Did you think 1 was more than 5? Because if it is, give me all your money. I will trade you all my $1 bills for your 5s. This cannot be true. So the answer cannot be over here. All right? What that means is, let me get my shading out of here. The answer cannot be anywhere on this side of the line. It cannot be. Okay? Hopefully you see that. Instead, we need to check the other side of the line. So let's check that. I'm going to check something over here in this region now. By the way, if we check this side of the line and find that it's true, we already know that our answer is right because we just proved that it cannot be on this side of the line. This is not true, so the answer cannot be over here. Okay? Let's check this point right here. You know why? This point is -1, 1. Mike, what if I checked a point different than you? That's fine. You can check any points in here, any points at all. As long as you plug them into your equation, the equation will tell you if it's true or not. Okay? So let's try -1, 1 in our equation. I'm going to start by rewriting. Always. Y is greater than or equal to 5x. Let's put 1 in for y, because that's what we have here. And let's put -1 in for x. 1 is greater than 5 times -1, which is -5. Is 1 greater than -5? That would be a heck yes. Okay? This is true. Therefore, our answer must be in this region. And we have double checked it because the answer could not be over here. Congratulations, ladies and gentlemen, them and theys. Your answer is indeed this. A straight line with no dashes. Uh-oh, kind of jagged there. A straight line with no dashes that is shaded from the line to the left. Okay? Technically, this shouldn't be shaded over here, okay? That's just me being messy. Got it? Now you try a couple here on your own. I'm aware that y'all may need to know some stuff about word problems. Let's just start here so you can even recognize what to do, and then we will go from there. Okay? So I'll do those in a separate video just to clarify. All right. Let's do. Here's a tricky one. It's not really tricky, but okay. And the equation for this line is y is greater than 4. Okay? You can tell it's greater than because you see the dashed line. And you also notice there is no equal sign under here. It just says greater than. Okay? That's why we have the dashed line. Okay? Pause here and figure out which region you're shading. Are you shading down or are you shading up? Make sure to test your answer. So test a point from your shaded region to prove that it is correct. And test a point from the other side of the line to prove that it is that the opposite is false. Okay, if that was confusing, just put in a point to prove your statement. All right, ready, set, go. Pause me here as I'm going to give you the answer in 3, 2, 1. All right, let's test it. Remember, I will always encourage you to try 0, 0. Now, notice this just says y is greater than 4. There is no x here. So you don't even have to check x for this. You're just checking y's. So if you take 0 and put it into your equation, you would get 0 is greater than 4. Is that true? Oh no! Okay? No way. All right? Instead, let's check a point that is somewhere up here. Okay? Let's check. Let's see. This is 1, 2, 3, 4. Let's try 5, which is right here. Is 5 greater than 4? Yes! Okay? So your answer would have to be here. Your answer is in the region above the dashed line. And think about it. This makes perfect sense. You said y is greater than 4. Well, the y-axis is the one that goes up and down. So all you have to do is just go up from wherever y is 4, which is right here. Y is 4 here. Do you see that? Bloop, bloop. So all the answers have to go up from here. Now here's the catch. Since this is a dashed line, you can't shade on the line for this. You need to be shading above the line. Because you said y is greater than 4, which means it cannot be equal to 4. So don't you dare shade 4 in your answer. Because 4 is not bigger than 4. It is equal to 4. And we did not say equal to 4. We just said greater than. So do not shade 4 for this. All right? Okay, let's do another one. Let's do y. Or sorry, I need to draw the line first, right? All right, we're going to do a y is less than this time. I can see that the y-intercept is at, looks like -4. And let's see what that slope is. Let's do 1, 2, 3, 4, up 4, 1, 2, 3, 4, 5, and over 5. Man, we just keep getting fractions, huh? That's all right. Don't run from it. All right. So, let's draw a line. Yikes, crooked line. Shady line. Still shady line, but whatever. Let's just go with it. All right? Now, again, we don't know which answer is it. It's either going to be up here or it's going to be down here. We do not know. We're going to plug in points to find out, okay? Go ahead and pause me now, and let's figure out what direction we're shading. By the way, before you pause me, did you notice I drew this line wrong? This is a less than sign. There is no equals there. This should be a dashed line. This should be a dashed line, okay? So let's make it dash the lazy way by erasing out parts since we realized we did that after the fact. Oof. Okay, got it? All right, now give it a shot. Pause me here. All right, answer incoming in 3, 2, 1. All right, hopefully you used an easy point like 0, 0 to discover if this is in the region or not. Because remember, we're either shading above the line or below it. We're not going to be shading on the line at all because this does not say equals to. So the answer is not going to be on the line at all. It's either going to be above it or below it. Let's figure it out. All right, so let's try 0, 0. I'm going to plug in 0, 0 for this to see if it is above the line. 0 is less than 4/5 times 0 minus 4. Therefore, 0 is less than 0 minus 4. Therefore, 0 is less than -4. Is that true? Is 0 less than -4? No, because remember, negative numbers is less than 0. That's what makes it negative. You went below 0. So no, that could not be true. All right? 0 couldn't be less than -4. -4 is smaller than 0. So this region has to be false. This is false. And the answer cannot be here because the statement doesn't make sense. And remember, math has no feelings. Math is not personal. It tells you how it is. The end, baby. Okay? So with that in mind, let's check the other region. Let's check a number down here. Now, I recommend you take some number that's on an axis because it's gonna zero out, all right? If you did not take another number on the axis, kudos to you, but I'm taking it, all right? All right, so I'm gonna do, let's see here. How about, all right, so this is -1, -2, -3, -4. All of that is in the above region though. We're not messing with the region up here. So we need to go down either here or something like that. I'm gonna take, let's see, this is -5. I'm gonna do -6 since it's right there. All right, so fine. I'm gonna do 0, -6. Why is it 0, Mike? Didn't you just say it's -6? The x is 0. Remember that? The x is 0 for this because we're on the y-axis. The -6 is -6 because we're on the y-axis, or we're on the y-axis. Okay? All right, so let's plug that into our equation, which was y is less than 4/5 x minus 4. Let's go ahead and put in -6 for y and put in 0 for x, so we ain't got to deal with these fractions. -6 is less than 0 minus 4. Therefore, -6 is less than -4. Is that true? Absolutely. -6 is more negative than -4, so it's less than it. Because remember, negative numbers get smaller and smaller and smaller. They go more and more and more opposite. So -6 is less opposite than -4. Or rather, in our case, less value than -4. Congratulations. You just proved that shading beneath the line is your answer. And you also proved that anyone shading above the line is capping. Great job. Next. Let's graph the line of y is greater than or equal to 2x plus 3. Okay? Yoink. All right. And we know that because our y-intercept is right here at 3. And we went up 2 and over 1. Okay? All right. Pause me here and work this on your own for sure. The next 2 you're going to work on your own, and then we're going to call it a night because it's almost 9. All right. Answers incoming in 3, 2, 1. Alrighty, remember that and if you haven't paused yet, you can pause after I make this statement, that your answer should either be beneath the line or above it. Also, make a note that we have an equal sign here. So this line should be solid, and it is, okay? Now, let's go ahead and check. I recommend always check your 0, 0. It's the easiest. There's no reason not to be checking 0, 0. So if I'm checking 0, 0, what I'm really checking is the whole region that 0, 0 is sitting in underneath the line. So I'm checking all of this solely by checking 0, 0. Isn't that nice? Not technically true, but true enough for today. All right? Because you're not really going to mess with that until you start constraining and dealing with systems, but we're not dealing with systems today. We will do that later. All right, now let's plug in 0, 0. Okay, so let's do 0 is greater than or equal to 2 times 0 plus 3. Therefore, 0 is greater than or equal to 0 plus 3. Therefore, 0 is greater than or equal to 3. Is that true? That would be a hot no. You're capping. The answer cannot be up here. That is impossible. Wait, I'm sorry. The answer cannot be down here. That is impossible. Here, I'll write it. Stop the cap. It's not down here, okay? Impossible, okay? Because 0, 0 did not prove true. And 0, 0 is beneath the line. If 0, 0 isn't true, nothing else in the same region is true. And this same region is beneath the line this time, so nothing beneath the line is true. Instead, let's test a point above the line. Okay? I'm going to go ahead and erase this here. If you need to refer to it, go ahead and Here, go ahead and pause here so you can see the work, because I got to erase it this time. All right? Okay, we're going to test the region above the line this time, because something above the line should be true, since we just proved the inverse was false. Okay, so something out here should be true. Let's find out. I'm going to take the easiest thing possible, because working smarter, not harder. Okay, let's see, this is 1, 2, 3, 4, 5, 6. Aha! So I see that 6 on the y-axis would give me a 0 for x. So I'm going to do this point right here, which is 0, 6. Why'd you choose this point, Mike? Because it's inside of our shaded region. Why's it got to be inside the shaded region? Because we're talking about inequalities, and you have lots of answers for inequalities, not one. So let's take 0, 6 and plug it in. 6 is greater than 2 times 0 plus 3. Therefore, 6 is greater than or equal to 0 plus 3. Therefore, 6 is greater than or equal to 3. Is 6 greater than or equal to 3? That would be a giant yes. You get a pass. We will keep you forever. Shade the region. This is your answer. Smiley face. Okay? Ta-da! That's your answer. A line for 2x plus 3, solid line, shaded up and to the left. How do you know that? You proved that the point inside of it is true, and you proved that the point outside of it is false. Stop the cap. Alrighty. Let's do 2 more, and then we will be done. Or actually 1 more, and then y'all just let me know if you want more practice problems. Okay? Because it's 9:03, so we're getting ready to wrap up. Last problem. All right. Oh, psych. Let's go here, and then let's go. So I'm constructing our line. Let's do greater than, not equal to, and I'm going to put our y-intercept at, looks like 1, 2, so -3. So I'm going to go and put my -3 out here. And then I'm going to go up 1, 2, 3. Here, let me do that in a different color. We're going to go up 1, 2, 3, 4, 5. And then I'll go over 1 just to keep it clean. So we'll do, so that should be 5x minus 3 because we went up 5 and over 1. And we're going to draw our line. Bloop, bloop. Okay, alrighty. Please graph or show me the answer for the following graphically, okay? Remember, we should be then either shading a region to the right of the line or shading a region to the left of the line. How do you know which one is which? Plug in a point from both. One of the points is going to prove false, and one of the points is going to prove true. Make sure that you do one from each side, and they will always be opposite each other. If a point from this side if a point from this side proves true, then the one from this side will always prove false, and vice versa. Okay? Take a minute, pause me. Answer incoming in 3, 2, 1. Okay. So I'm going to take the easiest point possible, 0, 0, and plug it in to try to make a statement. 0, 0 is where we start. 0 is greater than 5 times 0 minus 3. 0 is greater than 0 minus 3. 0 is greater than -3. That sounds lovely. We're happy. We will keep you forever. Now, what that seems to suggest is that this region here is probably true. But remember, I say probably because we haven't really said anything yet until we have checked the other region. Okay? So let's check this region down here. I'm going to pick an easy go-to axis answer. And I like to zero out x's too when I do this stuff. So I'm going to pick, I'll tell you what, I won't zero this one out though because this one's just closer. But I would recommend picking something down here because you're just going to zero out the x and that would be nice. But fine. We'll pick something on the line, on the x-axis. So in this case, it's going to be 2, 0. Okay? Because, you know, 1, 2. All right? And the y is 0 because we're on the x-axis. So let's put it in the equation. Y is greater than 5x minus 3. Therefore, according to this side, 0 is greater than 5 times 2. Here, let me put a tip there. There you go. 2 minus 3. Therefore, 0 is greater than 10 minus 3. Therefore, 0 is greater than 7. Is that true? Is 0 greater than 7? I think not. Let me do this. Y'all already know what I'm about to say. Say it with me. Stop the cap. Okay? Stop the cap. This down here cannot be true. Thus, you just proved that the region above the line is true. Good job. Now question. What's up with my line? Because this says greater than, not greater than or equal to. I should not be having a solid line here. Stop the cap. Let's fix it. Blip, blip. Whoa. I didn't mean to erase all that. Jeez Louise. Okay. Blip, blip. Blip, blip. Wow, that looks kind of bojank. Alright, well, I'm trying to make a dash line, y'all. Hang on. Let's do this instead. So my dashed line should be like this. There we go. Now, this, hold up, we got to get rid of this shaded region down here because that's not the answer. Ta-da! This should be our answer. We should have a shaded region to the left of the equation, okay? And the right side should not be shaded because we just proved that it is false. And that, ladies and gentlemen, is how you solve linear inequations graphically, okay? Now, there are, you know, obviously there are times where they don't have it in nice, neat y equals mx plus b form. I understand that. And I understand that you guys may need to do some stuff about word problems. We will talk about that too. But hopefully this was helpful. I'm going to try to put out another review for you sometime tomorrow. But these do take about a time, if you can see. By this video and the last video, these took at least 2 hours to do, not including setup and not including retakes. So I've actually been doing this for about 3 hours. So I will attempt to put you out another review for this, but please use your worksheets. Please come by the training center either tomorrow, if you see this at school tomorrow, or if you're seeing this at home on, you know, Wednesday, then come by on Thursday before the period of your test so that we can review these things and so you can go in feeling confident and better about this. I'm going to talk to your math teacher tomorrow about making sure that y'all have some time to come by and review if you need it, whether that be during your PE or during your elective, or if you have any spare class time. Please come by and practice. Grades are not an accident. They're just the end result of practice. That's all it is. That's why I call my passes practice passes. Till next time, best of luck. Hope that was helpful. And we will see you later. Insert